I'm just going to sneak out, give you the stage, Johan. Thanks. And I look forward to
awesome.
Your cool presentation.
Cool, thank you. Well, first of all, I want to do like a quick, I won't say a shout out, but it's really awesome. Like this is my home studio. So together with the ITQ team, we do a lot of customer sessions here or sessions with our like all staff meetings or whatsoever. But this is the first time we brought the community in and have a community event as well. So behind the stage is Jor, our producer. He's doing a really good job, and yeah, it's so awesome having community folks over and you know, talk about cool tech. So what I'm going to do right now is talk about one of my side hustles, if you will. So quick introduction. My name is Johan. I've been part of TeamRGE for the last 4 or 5 years. I'm a chief evangelist at ITQ CTO office, where I strongly focus on delivering the right message to our customers, but also you know, a little bit of prototyping and geeking out and seeing how of these geeking out projects we eventually are able to productize something. So it's also a little bit of R&D. It's an awesome job. So I got a thing for AI, and I've been working with AI or in the AI space for the last 6 years or so. I like to tinker around with my Jetson, but from a customer perspective, you know, I was the architect on a project where we build a VDI by day compute by night platform, where the customer basically by day can work on the VDI on the virtual desktop just from a workspace perspective. But at night, we completely repurposed the whole platform and used the GPUs and the CPUs for deep learning and machine learning workloads. So that's pretty cool. Another thing I did, and that's part of the last time I presented on TeamRGE, was Project STIG. I wanted to know more about deep learning. So basically, tried to train a model, an RNN, and use the RNN to basically play the game of Mario Kart. So Mario is capable of mimicking my driving, and my driving was bad, but yeah, you could also see that in the video. So I wrote a couple of books on the topic of VDI, and if you want to download those books, there's 2 QR codes that you can scan. You can download the books completely for free. So enough with the introduction and the talking about me. Let's focus on the current state of artificial intelligence. So unlike the other sessions, I'm 100% going, well, 92.3% going to focus on AI and a little bit of VDI, but I'll come to that with a bit later. So the history of AI. So as you can see here, deep learning is mostly what we're looking at today. Machine learning has been around for a while, and the first neural networks were created in the 1950s. Well, that's not entirely true, because if you look at this guy, which I hope that you guys know who this is. It is Alan Turing, and Alan Turing was part of a team that broke the Enigma code. So, and they used a very first form of a neural network, or artificial intelligence as we know it right now, and to break the Enigma code. So he created a Turing test, and I think currently that's one of the most important things that he's familiar for. So the Turing test basically states that if you have a user, an end user, or a person in this case, and you set up a conversation with a bot or a computer or whatsoever, and a human person, and you let him, in this case, chat, like, hi, I'm Heitepijn Harold, are you a bot? Well, in this case, he sends the question out to both instances. He gets a response back, like, no, I'm your wife. Oh, no, I'm your wife. Stop playing around with Minesweeper and clean the dishes. While his actual wife asks him, like, what's a bot? Well, in this case, he does not know who he's talking to. So the bot, in this case, probably has passed the Turing test. So artificial intelligence basically is currently categorized in 2 major forms of artificial intelligence. The first being general AI. So within general AI, you know, if you think about Gen AI or general AI, these are the common use cases. So Iron Man and Jarvis, who is inside his helmet and basically capable of doing literally anything. Or Arnold Schwarzenegger, who is part of Skynet. Skynet, same thing. Now, this form of AI is also something we call singularity, and to be fairly honest, although some scientists think that we are maybe close, if my neural network still detects a dog as a cat or an Ewok or something else, I'm pretty sure we're not there yet. So the second form of AI is called narrow AI, and within narrow AI, you can basically already look at narrow AI as something that you see in your day-to-day life. So examples are, and if you haven't seen the HBO series Silicon Valley, I highly recommend it. Jin Yang's seafood applications, who is capable of detecting if something is a hot dog or not, or AlphaGo. And there's a Netflix documentary called, I think it's actually called AlphaGo, where Google shows how they created a neural network that was capable of playing the world's most toughest board game called Go. And also, I won't spoil the result, but it is a very good documentary, so I highly recommend it. Now, something that we see right now, or something that we have seen in the last 12 months or so, are the rise of Gen AI. So ChatGPT, obviously, and DALL-E are great examples of that. Now, the session is called The Story of COBIE. So what is a COBIE? Well, COBIE is not an it. Well, it could be an it, but we kind of treat COBIE as a person. I was looking for a side hustle for a long time. And, I've the F1 sim on VDI, or tinkering with Mario in that case to figure out how deep learning works. All sorts of side hustles I've been, playing around with in the last 6-7 years or so to learn new stuff. And I wanted to learn new stuff as well, but I couldn't really find the right use case until it hit me. So for the people that follow me on social media, they might have seen that between the 1st of December and the end of January, I was on a sabbatical with my family. We spent 2 months in Indonesia. I spent time on another hobby I have, which is underwater photography and videography. And basically, I won't say hunt down turtles, but look for turtles, or look for nice fish and see, put them on camera. But while I was doing that, who takes care of the VHoyan.nl brand? Someone needs to take on my responsibilities as a VDI enthusiast. So a new project and side hustle was born. So the project, build a chatbot, sounds relatively easy, but I had some requirements. It needed to pass the Turing tests. It needs to know what I know, which is a challenge by itself. It must be biased, because to be fairly honest, I have a strong opinion on things like roaming profiles. Like, whoever created roaming profiles is the devil. That's my humble opinion. So I wanted to have the same kind of bias in the chatbot, which by itself poses a challenge. Now, what I always like to do, and that's something that was completely forced in by the VCDX methodology that I learned throughout the certification, is to find requirements, risks, constraints, basically start designing. And throughout the process, I needed to make a couple of design decisions. So first one, am I going to consume a public service, or am I going to build something private? Am I going to host that on-prem in my own lab, or host it in the cloud, which is nowadays, and I'll show that in one of the demos, is something that's fairly easy. Am I going to self-build something, or get something that's fully pre-packaged? Self-build is, from a tinkering perspective, maybe if you're a real geek and like to figure out how how composing a Docker image works, and what type of frameworks to put in and how all compatibility between the different frameworks work. You know, it's very fine, but I'm also quite impatient. So yeah, I need to figure out a way to avoid that. So let's dive into the individual design decisions. So first one, public service or private AI. Now, you know, it's really simple to just swipe a credit card and consume a public service. It's, you know, take ChatGPT. If I would feed all of my information into ChatGPT, done. But there is a challenge with that. And let's cover some of those challenges. So one of them is the fact that I want to know who owns the data that I feed into a public service. No one will tell you that. So there's no disclaimer or there's no documentation that clearly states that if I feed something into a ChatGPT or into a GPT 3.5 or 4 model that's hosted by OpenAI, that it's my data. So that's a challenge. Second one is that although like a large language model and a chatbot are not always right. It's not factual data that they present. It's something that someone feed into them. And if you have a real good conversation with, in this case, ChatGPT, you might be able to change the outcome of the answer. What an AI framework does is generate an output, and the output is always based on a prediction or a predictability, or you know, it's not 100% assurance that the model can give you. So in this example, like if you ask the right questions or give the right feedback to the model, it'll surely change its opinion. Now, next challenge when consuming services from a cloud is related to, well, putting all of your eggs in one basket. In this case, what happens if that basket gets a new CEO, or the CEO moves on the 18th of November, and the 20th of November, you know, he gets hired by Microsoft, and the 22nd of November he returns as a CEO to OpenAI. In this case, like if all of your eggs in that basket highly depend on a single person, I think that's probably going to be a risk by itself as well. So my decision I made was, and you probably can already guess it, is not to go for a public service, but to go for a private AI solution. Now, next question, am I going to completely self-build this, or am I going to try to figure out something pre-packaged? And I already kind of spilled the beans, but like, and this is the only marketing slide I'll show you during the entire session, but VMware launched something called they call VMware Private AI Foundation, and it is a platform consisting out of hardware, hypervisor, OS layer, or in this case, a containerization layer. On top of that, we see frameworks and the capability of inject models from different kind of sources. So the whole platform basically acts literally as a platform. You buy this from VMware or from one of the hardware vendors, and you basically, with the right tooling in place, are capable of spinning up a platform that's capable of running private AI as well. But my home lab is not really capable of running this, so that's a challenge. On the other hand, like self-building it is also problematic. So the question to the audience, and I don't have direct feedback here because Esther is probably having some Chinese food, but I am wondering, and maybe you can show a thumbs up in the attendee list. I don't know if that works right now, but who has ever tried to build a do-it-yourself AI platform? And again, I don't have any feedback, but like if you've tried it, you know it's a thing. And I'll call it something different at the end of the presentation. But this is literally how the process went when I first started building my own AI platform roughly 7 years ago, when NVIDIA's NGC didn't really exist yet. So I built and this is the flow we followed for a customer. So you basically build a VM, put, in this case, Ubuntu on it, a specific version of Ubuntu. So you can see it's 16.04 LTS. It's already based on a little bit older software. You update the packages after you deployed the OS. Then you install the NVIDIA drivers, but it fails because you need make and GCC to do so. Then after installing make and GCC, you successfully install the drivers. Then you install Python, because most of the AI-related applications are built on Python. In this case, the customer needed TensorFlow, so I installed TensorFlow on top of that. CUDNN, which is a deep neural network framework tied to CUDA, so that's part of what you need to run certain neural network applications. Then we ran a test script from the customer, which failed because, there we go, you need TensorFlow GPU to do so, and that's not part of the framework. So we installed TensorFlow GPU, then we tested the script, which successfully ran, which is good. Then, after that, we tested the application of the customer. That failed because we needed a specific version of TensorFlow. So that was TensorFlow 1.14 and TensorFlow GPU 1.14. We tested the app, which failed because a specific CUDA version is tied to a specific driver and a specific version of TensorFlow. So that, oh man. Then we tested the app, which failed because a specific version of CUDNN is required as well. Tested the app, which failed again because if you have multiple versions of CUDA installed on the same machine, you need to adjust the paths tied to a specific application, so it executes or includes the right libraries in this case. So we tested the app, which failed because apparently 16.04 was not supported. So this whole process of mainly anger management was something we basically found out in a 3-week engagement. So after 3 weeks, we were fully frustrated by the fact that it is true voodoo. Building your own AI frameworks or your AI application platform all by yourself is complete voodoo. So this is fun fact. People in the Netherlands probably know this guy, Mike Levy. Outside, he's American, but no one in the US knows who Mike Levy is. So that's, I presented the same slide in the US at VMware Explore with 150 people in the audience, and I asked, like, literally, who knows this person? And no, just one hand raised, which was of my colleague. So, and he's Dutch. But there is a better way. So, and this is really cool. So in the time that we were with the customer, the NGC platform from NVIDIA was released. And now things are completely different. So you take a VM, you install Ubuntu, choose the right version in this case, update the packages, make and GCC are installed, you install the NVIDIA drivers, install NVIDIA Docker, pull a TensorFlow container from NGC, and Bob's your uncle. Like, what NVIDIA did is really awesome. They created an online repository of completely prepackaged not just frameworks, but applications. So you can download a specific model for a RAG. So oh man, R augmented. Good, I forgot the name. But well, for specific applications, if you have an application that needs to like act as a chatbot, you have a specific application package for that contains not just the application framework, but also the underlying CUDNN framework, the underlying CUDA drivers. Every single thing that needs to be included is part of that package. And what's really cool is with every single version of, for instance, TensorFlow or PyTorch being released, NVIDIA releases a new container that contains all of those individual frameworks with compatibility. So if your code is, or your application is in Git, it's just a matter of creating a new CI/CD pipeline, putting in the right version of the NGC container, and you're done. So it's fairly simple to upgrade your application stack or the framework stack and keep your application like it is. Now, a second one that was well, it's a bit newer. A repository is Hugging Face. So Hugging Face, I don't know how old it is, probably somewhere like 3 or 4 years old. But this contains applications like the NDC platform does, but it contains much more, because what's also part of Hugging Face is models, is the application itself, and I'm going to show that in a demo. So result of the design decision is, in this case, I'm not going to build it myself. I'm going to go for prepackaged applications. Now, the last design decision, on-prem or cloud hosted. You can put a prepackaged or a pre-built application in a private AI platform. You could put that in the cloud, or you could put it on-prem, completely dependent on where you want to host it. In my case, you know, I want to act like a customer, so I wanted to protect, in this case, my crown jewels, which is the books. So I wanted to treat it as Fort Knox. Now, what we have seen in the last year or so, and I think this is a news item from a couple of months ago, September if I'm not mistaken, yeah, you know, consuming or putting your data in a kind of private AI platform online poses a risk by itself. What happens if the data gets stolen? So in my case, I wanted to put the data as much in-house as possible. Another one, and I'm going to quickly go over this, another challenge is what happens if the data and the bot and everything that is in the cloud is not secured enough. And not just security from like I'm going to put a firewall around it or do behavior analytics. No, AI has a other form of security that you need to be aware of, because you need to put guardrails around it. So I don't know, by show of hands or thumbs, probably no one will interact, but I don't know who remember Tay again. So Microsoft Tay was a chatbot developed to integrate in Twitter and interact as an end user in Twitter and learn by what she was seeing in the on Twitter. So in 24 hours, literally 24 hours, Tay went from, and this is the 23rd of March, 8:30 p.m. at night. She was really happy. Then the next morning, she turned less happy. So she just hated everyone. Literally 3 hours ago, she hated feminists and she wanted to let them all burn and die in hell. And this is 4 minutes later, it was a raging Nazi. So this is a perfect example of, you know, you need to guardrail it. And that's what's, I think, one of the most important aspects of putting that platform in your environment as well. You have the opportunity to guardrail it. Now, I'm going to quickly just go over this. One thing that's really cool is NVIDIA built a framework called NeMo guardrails. If you put it around it, you can not just contain it, but also adjust both the bias as well as the toxicity. If you want to start out with NeMo guardrails, there's the QR code. So I think I still have 4 minutes. And I hear an echo. Oh, that's gone. Okay, so design decision, go for on-prem. So introducing COBIE. So with all of these decisions made, you know, I knew what we needed to build, or I needed to build, and so we introduced COBIE. So who is COBIE? COBIE is our communications and operations bot for information exchange. So who is COBIE? COBIE is based on an OpenAI GPT 3.5 model. The application itself is built based on LangChain. It's trained using my 2 books, so VDI Design Guide Part 1 and 2. It is very biased, so that's really good, to be honest. And it has an integrated chatbot. So it is freely available on Hugging Face. So if you go to Hugging Face and Google or search for COBIE, you'll find the application. Just look for Johan, and in the next demo, I'm going to actually show it. So I'm going to show how to set it up on Hugging Face, or how we set it up. I'm showing the COBIE space, the space settings, and the Docker command to pull it. So bear with me. If all goes well, I should be able to put this either that way. Yeah. There we go. Right, so this is Hugging Face. And if you look at Hugging Face, you can see all sorts of spaces of the week, like new spaces that have been created. And again, if you search in spaces for COBIE, oh, typo, COBIE, nope, COBIE, yes, there we go. What's really cool about Hugging Face is that every single space that you create, an application that you launch, is actually executed. Every space has a little bit of resources, and if you look at the resources that you get allocated for free, and that's pretty cool, is 2 virtual CPUs and 16 gigs of RAM. So it's probably oversubscribed, but honestly, I don't care. If I want to just test a little bit of code into like what I changed in production, I'm checking it here. But for just 60 cents an hour, you can also run it on a T4. And if you just want to test something on a GPU, I think this is really, really awesome. Don't forget that if you're going to use it on a GPU, to change the visibility of the space to private. In this case, COBIE is public because I want everyone to use it. And they can also use it online. But if you assign a GPU to it, that means that everyone can use the same GPU online as well. And that ends up in your credit card. So that's not good. Now, I'm going to quickly go to the second demo. So one thing you need to know as well is that an application downloaded from Hugging Face consists out of, it's a Docker image. It consists out of multiple different frameworks. And it has a installation file, a requirements file that consists all of the frameworks that automatically import it. What happens if you pull the Docker container, which in this case I think is roughly around 6 gigs, it also tries to inject models, other frameworks, drivers. So everything is being injected during the pulling of the container. So you need to be aware that if you pull a container like that, it'll probably cost you around 12 gigs of space. So you can actually see COBIE here. I integrated it with OpenAI because I didn't want to build my own model from scratch. That's something for on the roadmap. And I fed multiple different PDFs based on my own books into it. So we can now basically just ask questions. So who is... And books, the last book was released in 2021. Who is Ruben Sprout? It should be able, because Ruben was so kind to lend a hand on the first book, and I had an interview with him. So COBIE actually knows who Ruben Sprout is. Project Virtual Reality Check. That's old.
That's old.
Now, he also knows, because I already tested this, what famous quote, and I don't know if Sean is still in the call, what famous quote is Sean Bass known?
System overload.
Is known for saying that after nuclear war, only 3 things will still exist: cockroaches, Twinkies, and Windows apps. So final thing I would like to ask, do you like roaming profiles? And it's not as rude as I am, so it is biased. Oh, really? Well, this is nice about a live demo. They can call, well, okay, so it creates just a political correct answer. It says that there's issues, I won't use them, use something else, blah, blah, blah. In my book, I literally quoted, like, they're made by the devil. Now, let's go back to one final slide before I close down. I think I'm just a little over time right now. Yes. So we looked at Hugging Face, the COBIE space, space settings, the Docker command. You can copy the Docker command from the space and just pull it in your own environment. So I didn't build this, but I built it a little bit like this. Right, so we fed a PDF, tested the prompt, tested the bias, and fed a question into it. Now what's next? we have a roadmap. So I'm going to actually move it to what we call an ITQ experience lab that has multiple A100s, and we are actually capable of feeding much more complex information into it. We're going to migrate to Mistral, which is a different model and definitely capable of handling much more complex information, which also offers multi-GPU support. We're going to look at a distributed architecture. So in this case, it's a single container that has everything, but we want to look at a distributed model where we can scale up certain components if necessary, but also replace certain components if necessary. And we're going to implement NeMo and guardrails. So it's not running on NeMo right now. It will be running in NeMo next. And we'll put the guardrails around it to actually manipulate the bias and the toxicity. Now, some lessons learned. Do-it-yourself AI is voodoo. Don't just like screw around. If you do something, if you're going to tinker, write down what you did, because it's the only way to go back to like knowing what you actually did to make it work or to screw up. I think you should not trust anyone with your data. And finally, think before you act. So if there are any questions, Esther will probably see them in the chat. If not, you can drop me an email or a message on X, or drop me an email at johan@itq.nl, and I'm happy to help out. So that was it. Woo! Cool.